ସାର୍ ନମସ୍କାର।
नमस्कार, सुना जाउची?
आज्ञा सर।
ओके, हमर केते 10 जन जॉइन 7-8 जन जॉइन कलानी आ जॉइन करिवे बोते आ टिके 3 मिनिट अपेक्षा करिवे। अच्छा, तमरो ना जो फर्स्ट बैच जो हम पढौतली तमर सेही बैच बोते?
आज्ञा सर।
जे म फ्लोजी पढैतली तमर बोते फर्स्ट बैच रे फर्स्ट सेमेस्टर रे मु पढैतली ना आउ के पढैतले तमर?
आज्ञा सर आपण पढैतले।
मोर डाउट करना पड़ता 2-3टा बैच हे गेलनी त पिला तेणु कंफ्यूजन होची। अच्छा, आज आम ओसेनोग्राफी पढ़ा थर्ड सेमेस्टर गोटे पेपर ओसेनोग्राफी। अच्छा, पावर पॉइंट देखा जाउची? अच्छा, पावर पॉइंट देखा जाउची?
आज्ञा सर।
अच्छा, मूव भी करूची स्लाइड मूव करूची?
आज्ञा सर।
ओके। अच्छा, हमर ए जो ओसेनोग्राफी रे कोन पढिबार अछि से विषय टी डिस्कशन कर दबा आज फर्स्ट ईयर रे। आ काली की स्पेसिफिक टॉपिक ऊपर को जिबा जो जाक डिफिकल्ट टॉपिक्स से जाक जिबा जनरल लाक डिस्कशन कर दबा आज। ओसेनोग्राफी हला दिस इज द स्टडी ऑफ द ओशंस। अच्छा, हमर जेमती क्लाइमेटोलॉजी आ मेटेरोलॉजी दीटा सब्जेक्ट अछि व्हिच एक्सप्लेन्स अबाउट द साइंस ऑफ मेटेरोलॉजी आ गोटला क्लाइमेट्स ऑफ द वर्ल्ड। जे बेसिक डिफरेंस जेमती हमें पढ़ी जियोग्राफी रे क्लाइमेटोलॉजी किंतु तार गोटे साइंस भी रही दैट इज मेटेरोलॉजी। सेमती हमर ए ओसेनोग्राफी हला गोटे सब्जेक्ट जोटा कि डील्स विथ द डिस्क्रिप्शन ऑफ द ओशंस एंड ओशन रिलेटेड फीचर्स कैरेक्टरिस्टिक्स resources associates ये सब जिनसे देखो description and which is mostly related to the ocean. But there is another parallel subject also to oceanography that is called marine science. They also deal with oceanography but in a different way where they are more towards science of experimenting on the oceans. But semantical experimentation it may be exploration of the what is there in the biodiversity of the ocean. What is the physical characteristics of the ocean? What are the chemical characteristics of the ocean? What are the ocean related structural disturbances, geophysics of the oceans, paleoorganism of the oceans. ये सब बहुत गुड़े जिनसे रही है जो कि they are a part of understanding the science behind the oceans. That goes as a marine science. There is a overlapping area between marine science and oceanography. Like the oceanography is more towards a description of the oceans and the ocean related information, ocean related attributes, characteristics, resources, and other phenomena related to the ocean. And this oceanography is also part of study of the hydrosphere. And hydrosphere relates to the water availability of water on the surface of the earth. ତା ଭିତରୁ the major component of the water is inside the oceans. ଆଉ ତାପରେ ocean covers about 70% of the total area of the earth surface and covers about and contains about 97% of the global water. ଆମର earth ରେ ଯେତିକି ପାଣି ଅଛି ତାର 97% is stored in oceans. ଆଉ ବାକି 3% ମାତ୍ର or less than 3% is all other water other than the ocean water. All other water money, water in the form of ice, surface water in the form of ponds, lakes, wells, rivers. ଆଉ ଯାହା ଯାହା ଯୋଉଟା ଅଛି fresh water body ସବୁ ମିଶିକି 2.7%. ଇଏ ହେଲା 97.3% of the ocean water. And 70% of the earth's surface is covered by. ତେଣୁ ଆମେ ଯେତିକି ଦେଖୁଛେ whatever we see as the topography of the earth's surface, that is the lithosphere ର ଯୋଉ portion ତକ expose ହେଇକି ଅଛି, that we see that constitute only 30% of the earth's surface and 70% of the earth's surface is covered by the ocean. ତେଣୁ ତାର ocean bottom ରେ ବି ସେମିତି ବହୁତ ପ୍ରକାର relief features ରହିଛି, like mountains, valleys, plateaus, plains, quays, mounds. ଏମିତି ବହୁତ ଗୁଡେ ଜିନିଷ ରହିଛି, just like our what we see over the land. Then oceanography makes a complete understanding of the ocean water characteristics, ocean surface characteristics, and ocean water movement characteristics, and ocean water related biodiversity characteristics. ଏମିତି କିଛିଟା ଜିନିଷର description ରହିଛି oceanography ଭିତରେ, which relates to the man and his environment. It is a part of the man and environment, and in that perspective, there is a lot of variation in the nature of oceans according as per the distribution over the earth's surface. So we are interested in studying this oceanography as a part of our geography as a complete paper, which talks about the distribution of. So if we go to the topics individually, it is the distribution of ocean water on the surface of the earth, or the distribution of oceans of the water bodies, creation of the water bodies, origin and formation of the water bodies, origin of the ocean water, the physical properties of the ocean water, that is physical property mane the movement of ocean water in the form of waves, currents, tides. The chemical properties of ocean water, it includes density, it includes salinity, it includes other important attributes of the physical attributes. Then also it talks about the distribution of species on the ocean surface, which may be of three different types, the different types of species dekha janti. Gote hele a category of species which are floating on the ocean water, another category of species which are swimming or moving in the water, in the ocean water, and the third category is a group of plants and animals which are rooted to the sea floor. You know, there are different types of species. So the biodiversity is also very large. So it comprises of benthic species, it comprises of necton species, it comprises of also plankton species. So like this, there are three categories: planktons, nectons, and benthos. Three categories of species of large varieties, which may include the smallest fish to the largest whales, and many other species of plants also, from diatoms and the smallest atomic particles of the plants to the large plants also inside the ocean water. And simultaneously also the physical oceanography comprises of movement of ocean water in the form of, because the ocean water is constantly mobile because of the attraction of the tidal forces of the sun, moon, and the other celestial bodies. So constantly the water is always in motion under the influence of this, and also simultaneously under the influence of the wind, which is pushing the water to move towards the direction in which the wind is moving. So that also implies study of how this wind drives the water, how this tidal forces drive the water. So we try to get into the waves, the different types of waves that we see over the earth's surface in the oceans. The wave may be on the shore, along the shore, or maybe on the high seas. There may be normal waves that you see just along the coast, or there can be swell waves that also occur, the hues form in the deep inside the sea. There are we never observe a swell wave. Swell wave is a mass of water rising, huge amount of water. So that is something unique that you see if you go into the southern hemisphere. The people who are the mariners, they travel in high seas, they will experience these swell waves. And similarly, there are tidal movements also, current movement also. So there are different types of movement of ocean water in the name of waves, tides, currents, and of different types also. And then we have another other phenomena like the distribution of the biodiversity in the oceans, distribution of mineral resources in the oceans, distribution of the sediments in the oceans, which are a source of different types of minerals. So, like this, we have a lot of things to study in oceanography. So, which is a part of our study at the moment. So, we will be discussing all these things which are there in your. There are two blocks which are available to you, block 1 and block 2, comprising 7 units. 7টা unit ତମର ଅଛି ତା ଭିତରେ. So, it's entirely discussing about all these aspects of the oceanography. Okay. ତେଣୁ ଆମେ ଯଦି percentage ହିସାବରେ ଦେଖୁଛେ, oceans contains 97.3% of the water. ଆଉ ବାକି ଯୋଉ ରହିଲା 2.7% of the water, ତା ଭିତରୁ 2.1% ହେଲା ocean. The surface water is associated with the glaciers and polar ice caps in the cryosphere. That is called cryosphere. ପାଣି ଯେତିକି 97.3% ocean ପଳେଇଲା ପରେ ବାକି ଯାହା ରହିଲା ତା ଭିତରୁ 2.1% is underground ରହିଲା 0.6%. Lakes, rivers contains only 0.01% of the total water resource of the world. Atmosphere ରେ moisture ହେଇକି vapor ହେଇକି cloud ହେଇକି ରହୁଛି 0.001%. Biosphere ରେ ଆଉ smallest amount of water ରହୁଛି ସବୁଠୁ. So this is how the water is distributed in different aspects of the earth, and ocean contains the 97.3%. So we are studying up this, what it contains. ତେଣୁ ଏଇ ଯୋଉ 2.8% ବା 2.7% ଭିତରେ ରହୁଛି ଆମର ଗ୍ରାଉଣ୍ଡ ୱାଟର କେତେ, ଗ୍ଲାସିଆଲ ୱାଟର କେତେ, ସରଫେସ ୱାଟର କେତେ, ଏଇସବୁ ଜିନିଷ. ଆଚ୍ଛା, ଫିଜିକାଲ ପ୍ରପର୍ଟି ଭିତରେ ବି ଆସୁଛି ସି ସରଫେସ ଟେମ୍ପରେଚର, ସି ସରଫେସ ପ୍ରେସର, ଦେନ୍ ଆଟମସ୍ଫିୟରିକ within the water also there are temperature, pressure, distribution of sunlight, and many other phenomena are also coming as a part of this simultaneously also. The origin of the oceans, origin of ocean water, and many other things are also there. The tidal hydrological cycle which feeds the water, feeds the water to the oceans and then evaporates from the ocean to again in the vapor form goes to the atmosphere, becomes the cloud, and then again precipitates and the water drains to the oceans, and then again the cycle completes. You know what the hydrological cycle is? This is one of the major source of moisture to the atmosphere, and that is how the water distribution and the balance takes place over the earth's surface. Okay, the topographically যদি দেখি, if we see it from a topographic point of view, we see the part of the earth's surface at an altitude of about whatever is the highest peak of the earth, highest altitude of the earth is found in Everest, that is about 8,448 meters, approximately 8 kilometers. But you find the distribution of land mass inside water is much more than this, much deeper than this. The maximum depth to which the water is there is about 11 kilometers in Mariana Trench. So depth is more in ocean than its height over the land surface. And accordingly, this is what is also the area under different heights. That is what is called the hypsographic curve. This explains about. I am just giving a brief idea of your courses so that you will find a linkage between different things that you will be studying in your blocks. So if you distribute the land surface available over the earth surface, and this is the sea level, so above the sea level, the land distribution is like this. So within 30% all the earth surface area exposed to this surface is there in this pond with this altitude of 7-8 kilometers to about the sea level. So from sea level below, you find the ocean depths are like this. So based on this depth, you can find out there are three zones of the ocean. So this zone is this close to the sea level is the continental shelf zone. তারপরে এই যে জোনটা দেখা হচ্ছে স্লোপিং দিস ইজ কল্ড দ্য কন্টিনেন্টাল স্লোপ জোন তারপরে এই যে জোনটা দেখা হচ্ছে সেইটা দ্যাট ইজ হোয়াট ইজ দি ডিপ সি প্লেন্স অ্যান্ড দি ওশান ডিপস then this is how hmm চারটায় ଚାରିଟା ଦଶ ହେଲା ନାଇଁ ଚାରିଟା କୋଡ଼ିଏ ହେଲା so, so this particular graph explains about the hypsometric curve of the earth's surface showing the distribution of land mass in different altitudes above the sea level and below the sea level এই curveটাকে কুହାଯାଏ hypsometric curve বলে that indicates how much of area remains at what depth in the distribution pattern যদি এমতি ଗୋଟେ 3 dimension ରେ ଦେଖିବା if you look at the ocean in the 3 dimension like this from the continent to the deep sea plains তাহলে আমি normally will find there is a continental crust ଯୋଉଟାକି ଆମେ land surface ବୋଲି ଯାହା କହୁଛୁ close to the continental shelf ମାନେ coast this is the coastline adjacent to the coastline we have a portion of the sea to which we call it as the continental shelf এই যে portionটা দেখা ହଉଛି which is adjacent to the shoreline this is what is called as continental shelf continental shelf ପରେ ଗୋଟେ ଜୋନ୍ ଅଛି ଯୋଉଟା କି ସ୍ଲୋପିଂ ହେଇକି ରହିଛି ଟୁ ଦି deep sea plains ଏଇ ଯୋଉ ସ୍ଲୋପିଂ ଜୋନ୍ ଯାକ କୁହାଯାଏ this is what is known as continental slope ତାପରେ then gradually the slope merges into the deep sea plains of the ocean so we may call it the deep sea plain or the ocean deeps or the abyssal plains ଏମିତି ତାକୁ ଦୁଇ ପ୍ରକାର ନାଁରେ କୁହାଯାଏ ବେଳେବେଳେ କୁହାଯାଏ it is a deep sea plain ଆଉ ବେଳେବେଳେ କୁହାଯାଏ continental deeps or abyssal plains ଏମିତି ତିନିଟା ନାଁରେ ବେଳେବେଳେ କୁହାଯାଏ and the average depth of the ocean is almost about 5 to 6 kilometers in different oceans depending on that highest depth is in the Pacific Ocean and then the next highest comes to the Indian Ocean and then Atlantic ତେଣୁ ଏମିତି ହେଇକି ମାନେ we find the continental slope is this zone Achha, continental slope you can see a river is coming and distributing its sediments like this ଏଇଟା ହେଲା deep sea fans ଯେମିତି ଆମର ନଈ ଯେମିତି ପାହାଡ଼ରୁ ଆସିକି ଯେମିତି deposit କରେ alluvial fans ଯେମିତି create କରେ similarly here also inside the sea when the rivers come into the continental shelf and enter into the deep sea plain because the force of the water and the sediments gradually push themselves towards the deeper sea plains we find the trenches they are called as the trench so like this we have different type of features inside we will be going into the details but these are the three important zones one zone is continental shelf this zone is continental slope this zone is deep sea plains or the abyssal plain so later this is the continental margin which is close to the continent we call it the continental margin which comprises of shelf slope and a part of that deep sea plains then in ଭିତରେ we find the movement of ocean water in the form of currents waves tides and different type of phenomena we find different minerals we find different type of currents so like this there are various attributes of the ocean which we are supposed to learn in this oceanography So this is also the same type of axonometric curve which is shown in the 3 dimension. So the chaotic details of the features have been explained. So you find this is the continental shelf. Continental shelf bar into continental break ହେଇକି ଏଠୁ continental slope ଆରମ୍ଭ ହେଉଛି. Continental shelf ରେ ଆମର ରହିଛି coast line ପାଖରେ ରହିଛି there are barrier islands ଯୋଉଟା କି ଆମ coast ପାଖରେ ଯୋଉ island ଜାଗା ଭିତରେ ସମୁଦ୍ର ଭିତରେ formation ହୁଏ ଯେମିତି Hospital island ଅଛି କି ଆମର islands of the Chilka ଅଛି କି other islands which are there inside the sea close to the coast these are called as the barrier islands. ଏ ଯାକ ଦି ପ୍ରକାର ଅଛି barrier island ଗୋଟେ ପ୍ରକାର ହେଲା ଯେ sediment deposit ହେଇକି create ହୁଏ ଆଉ କିଛିଟା barrier island ଆଗରୁ ପାହାଡ଼ submerge ହେଇକି ଥାଏ mountain ରେ submerge ହେଇକି ଥାଏ so that acts as a barrier and barrier island ବୋଲି ତାକୁ କୁହାଯାଏ। ତେଣୁ ଆମର west coast ରେ ସାଧାରଣତଃ ଏଇ ପ୍ରକାର barrier island ଯାହାକି mountain remnant ହେଇକି ଥାଏ ଆଣ୍ଡାମାନ ନିକୋବରରେ ଏମିତି ବହୁତ ଗୁଡେ ଜିନିଷ ଦେଖିବାକୁ ମିଳେ କିନ୍ତୁ ଆମର ଇଷ୍ଟ କୋଷ୍ଟ ଯୋଉ ଜାଗା ଦେଖିବାକୁ ମିଳେ ସେ ଜାଗା ହେଲା those are barrier islands but mostly by the deposition of sediments। ତେଣୁ ଏଇଠୁ ଯୋଉ ଯାକ ଏ ଭିତରକୁ ରହେ ଏମିତି ପାଣି ପୁସ୍ କରି ଭିତରେ ରହେ ଏ ଯାକ ବେଳେ ବେଳେ କୁହାଯାଏ ଲେଗୁନ୍ ବୋଲି। ଲେଗୁନ୍ ଟା ଯଦି ଆଉ ଟିକେ ବେଶୀ ବଡ ହେଲା ତାହେଲେ ବହୁତ ବଡ ହେଲେ ତାକୁ କହନ୍ତି ଏପିକଣ୍ଟିନେଣ୍ଟାଲ ସି ବୋଲି ବେଳେବେଳେ ଇଟ୍ ଇଜ ନୋମେନକ୍ଲେଚର ଏଜ ଏପିକଣ୍ଟିନେଣ୍ଟାଲ ସି। ଆଉ ଦିଟା ଏଇ ଯୋଉ ବିଚ୍ ପାଖରେ ଯୋଉ ଜୋନ୍ ଟା ଦେଖାଯାଏ coast line ପାଖରେ କଣ ହେଇଛି ନା we find a beach. Beach is the area where the sediment deposition takes place or at times sediment erosion also takes place. ଦିଟା ଯାକ beach deposition ହେଇପାରେ କିମ୍ବା erosion ହେଇପାରେ। ତେଣୁ ସେ beach ରେ ଗୋଟେ ଏରିଆ ଅଛି ଯୋଉଟା କି ତାକୁ intertidal zone ବୋଲି କହନ୍ତି। Intertidal zone ମାନେ during the high tide the water will be coming towards the land, during the low tide water will recede towards the sea. In between that area ଯୋଉତକ high tide ବେଳେ ଆସିକି ପାଣି submerge करे that is called the intertidal zone. The intertidal zone is a very sensitive ecological zone जोटा कि lot of biodiversity is associated and beach formation activities are all related to that particular place. ତେଣୁ ଏମିତି ହେଇକି we find ତେଣୁ ଏଇଟା ହେଲା ଆମର intertidal zone ଏଠି ଦେଖଉଛି ଏଟା ହେଲା coast line ର ଯୋଉଟା land ଆଡକୁ ରହିଛି ଯୋଉ ଏରିଆ ତକ ସେ ଏରିଆକୁ କୁହାଯାଏ backshore zone ବୋଲି କୁହାଯାଏ। ଆମର coast line ଯୋଉ ଏରିଆରେ ଅଛି ତାକୁ କୁହାଯାଏ shore zone ବୋଲି। shore zone ର ପଛପଟକୁ ଯୋଉତକ ଏରିଆ ରହିଲା that is backshore zone। shore line ର front କୁ ଯୋଉଟା sea ଆଡକୁ ରହିଲା ସେଟାକୁ କୁହାଯାଏ offshore zone। ଆଉ ଏ shore zone ଭିତରେ ରହିଲା କଣ this coast line and the intertidal zone। ଏଇ zone ଟାକୁ ଆମେ କୁହାଯାଏ shore zone ବୋଲି। ତେଣୁ shore zone comprises of the beach and the barrier islands ଏଇ ସବୁ ଜିନିଷ ଯାକ ଦେଖିବାକୁ ମିଳେ। Normally we see all this। अच्छा ଶୁଣା ଯାଉଛି voice is clear?
ଆଜ୍ଞା
Yes,
ସାର୍।
sir.
ମଝିରେ ମଝିରେ ଯଦି କିଛି ଦରକାର ପଡେ ପଚାରି ପାର ନହେଲେ ଏମିତି ବସିବ ଯଦି ବୋର ହେଇଯିବ ପୁରା 2 ଘଣ୍ଟା। ତେଣୁ ମଝିରେ ମଝିରେ try to interact question ପଚାରିବାକୁ ଚେଷ୍ଟା କର so that we will be discussing also simultaneously ଖାଲି କହିବା ଅପେକ୍ଷା we may discuss something whenever it comes to your mind to ask something। ତେଣୁ ଏଇ ହେଲା ଆମର ଅଫସୋର ଏଟା ହେଲା ବ୍ୟାକସୋର ଜୋନ୍ ତାପରେ ହେଲା ଆମର ସୋର ଜୋନ୍ ତାପରେ ରହିଲା ଆମର ଅଫସୋର ଜୋନ୍। ଏଇ ଯୋଉ ଅଫସୋର ଜୋନ୍ ଟା କୋଉ ପର୍ଯ୍ୟନ୍ତ ଯୋଉଠୁ ଢେଉ ତକ ସୃଷ୍ଟି ହେଇକି ଆମର କୋଷ୍ଟ ଆଡକୁ ଆସେ ସେ ପର୍ଯ୍ୟନ୍ତ ରହୁଛି ଅଫସୋର ଜୋନ୍ ବୋଲି ତାକୁ କୁହାଯାଏ। ତେଣୁ ଅଫସୋର ଜୋନ୍ ର ଗୋଟେ ପିକୁଲାରିଟି ହେଲା କଣ that is a zone where immediately you find a lot of depth of water is less, sunshine ବେଶୀ penetrate କରେ ଭିତରକୁ। So the offshore zone is one of the richest zones of biodiversity in the sea। Entire sea ଭିତରେ ସବୁଠୁ highest number of biodiversity is found in the offshore zone actually। coastal shore zone ଆଉ offshore zone ରେ ବେଶୀ ଦେଖାଯାଏ because of penetration of water much deeper into the water of about 25 meters ପର୍ଯ୍ୟନ୍ତ sunlight penetrate କରେ। So a lot of phytoplanktons are grown in that and to eat that phytoplankton a lot of fishes used to come to eat those small fishes. Large fishes also used to visit and that is the reason for which we find a biodiversity which is more in the sea in the shore zone or in the offshore zone mostly or in the continental shelf also। You can say the continental shelf is the most rich biodiversity zone of the earth of the oceans. ତେଣୁ ଆମର ବର୍ତ୍ତମାନ ରହିଛି 5ଟା ଓସେନ ରହିଛି. There are 5 oceans: Indian Ocean, Atlantic Ocean, Pacific Ocean, Arctic Ocean and the Atlantic Ocean. ଏମିତି 5ଟା ଓସେନ ରହିଛି, separating this island, ଆମର ଯୋଉ continent, ସବୁ continent କୁ separate କରି କରି ରଖିଛି ଯଦି. ଆଚ୍ଛା, if you look to the origin of this ocean, କାହିଁକିନା ଆର୍ଥରୁ ଯଦି ସବୁ ତ ଓସେନ ବାହାର କରିଦେବା ତାହେଲେ କ'ଣ ହବ ନା, every part of the earth becomes a land surface, but you find there are places of high altitude, there are places of low altitude, there are depressions. ତେଣୁ ଆର୍ଥର କ୍ରିଏସନ ପରେ ଯୋଉଠି ଡିପ୍ରେସନ ଥିଲା, ସେ ଡିପ୍ରେସନ ଜାଗାରେ water has gradually been filled up and ocean has been created, and gradually the salinity has started coming into the ocean by drainage of ତେଣୁ ଯେତେବେଳେ ଓସେନ କ୍ରିଏଟ ହେଲା, ଡିପ୍ରେସନ ହେଇଗଲା ପରେ ଯେତେବେଳେ volcanic activities ହେଲା, earthquakes ହେଲା, and there is a lot of dislocation in the earth's interior, a lot of water vapor also come outside the crust because of the volcanic eruption and other earthquake related activities and tectonic activities. Water and oxygen combined together and has created water, and this water has slowly formed over the earth's surface, has drained into the ocean. While draining into the ocean, they have carried a lot of salt that is available on the surface of the earth, and gradually salinity has started adding to this. ତେଣୁ ଆମର ଯୋଉ ୱାଟର ତକ ଆ ଭିତରେ କ୍ରିଏଟ ହେଇଛି, ଦି ପ୍ରକାର ୱାଟର ଅଛି. ଗୋଟେ ହେଲା ୱାଟର ଫର୍ମଡ ଆଉଟ ଅଫ ଦି water vapor condensation by mixing of oxygen and hydrogen through the different type of earthquake related and tectonic activities. ଆଉ ଗୋଟେ ହେଲା called heddle water. Heddle water ମାନେ ଯୋଉ ଯାକ ଷ୍ଟୋର ହେଇକି ରହିଥିଲା ଭିତରେ crust ର formation ବେଳେ, ସେଇ ୱାଟର ତାକୁ ବି ରିଲିଜ ହେଇଛି ଡିପ୍ରେସନ ଭିତରକୁ. ସେ ହେଇକି ଏମିତି ଦି ପ୍ରକାର ୱେରେ ocean has been created and filled up with the depressions, has created the oceans. ତାପରେ gradually the salinity has also started increasing day by pouring of dissolved water from the land, carrying the salt laden water, taking to the sea and depositing inside, and the salinity has started increasing. ତେଣୁ ବର୍ତ୍ତମାନ ଆମର average salinity of the sea is called as 35 per million. That means 35 parts per million of water. ଯଦି ଆମେ 1000 parts ନଉଛେ, ତା ଭିତରୁ 35 parts ହେଲା by volume, that is the salinity. ତେଣୁ ଏମିତି ଭାବରେ ଆମେ ଯଦି ଗ୍ରାମରେ କନଭର୍ଟ କରିବା, 1000 ଗ୍ରାମ ଅଫ ୱାଟର ଭିତରେ 35 ଗ୍ରାମ ଅଫ ସଲ୍ଟ is likely to be present. That is the average salinity of the sea water. We call it as per mille, 35 per mille. But the highest salinity is found in the Dead Sea in Jordan. Jordan ରେ ସବୁଠାରୁ ଯୋଉ Dead Sea ଅଛି, the salinity is about 365 per mille. That means 365 grams of dissolved salt in water. That is the reason for which anybody who is thrown into the Jordan Sea, Dead Sea, they will never sink, they will float because of the high density of water. ଆମ ସିରି ଜାଗାକୁ ଗଲେ ତମେ ବୁଡ଼ିଯିବ, କିନ୍ତୁ ସେଠି ଜର୍ଡାନର ଯୋଉ ସି ଅଛି ତାର Dead Sea, ତା ଭିତରକୁ ଗଲେ you will never sink, you will float always because the density of sea water is very high. So that is and there is no species because of the high magnitude of salinity in the Dead Sea. So now we are slowly moving into these 5 oceans. So the ocean jaga jo creation heichi because when the continent started drifting. So our origin of the oceans are related to the origin of the earth itself. So earth origin ro jete jaga theory achi, सब theory jaga explains about slow kar de. So the origin of the earth, whatever theories that you have known, that is whether it is tidal theory, whether it is planetesimal theory, whether it is Big Bang theory, all those theories which are relating to the earth, they also explain the origin of the earth, and along when the origin of the earth has been explained, it also explains the origin of the land mass and the water mass. The water mass is the ocean and the land mass are the continents. So all those theories which are there in your study material, they explains about which you will be studying through those. These are very not very complicated. They are very simple things. As I know, there is a planetesimal theory, there is a tidal theory, there is a mm, continental drift theory and plate tectonics theory. So these are all the theories which are explaining about how the continents are formed and how the oceans have been named. Because once upon a time, the entire landmass was at one place and the entire depressions were at one place forming the oceans. So the land was called Pangaea and the ocean was called Panthalassa, which has been segregated by the drifting process and movement of plates. ତେଣୁ ସେଇଠୁ ଆମର origin of the ocean ହେଇଛି ଆଉ ତା ପୂର୍ବରୁ ଯୋଉ origin ହେଇଛି it is related to the origin of the earth itself. So the ultimate theory which explains is the Big Bang theory, that the explosion of a star and then distribution of the mass, celestial mass in different parts of the uh, space, and then formation of the planets, and then formation of the stars, some planets, and the uh, asteroids as well as the satellites. All these things have been formed, and then the condensation of this gaseous matter has taken place. And depending on the material composition of the matter, there has been differential cooling of the earth surface, and in this process there has been somewhere depressions, somewhere elevations. So elevation areas remain as mountains, and the relatively low elevation areas remain as the continents, and the deeper areas or the depression areas remain became the ultimately the ocean. So gradually the water started filling up into those depressions. And since the earth is in a rotational process, the water is not falling to the space, it is very much being attracted by the earth's gravitational pull, remains in a revolving earth. So you don't find that the water is falling down from the earth's surface. And the water constantly in movement continues to move along with the earth itself. Just like our atmosphere is also moving, similarly the ocean water is also simultaneously moving along with the, so when the earth is rotating and revolving around the sun. So after the formation of the earth and then after formation of these continents and then distinction of the oceans, that has come up by shifting of North and South America. So you have created the Atlantic Ocean was created, North Atlantic, South Atlantic, and then on the other side of this North Americas and South Americas, and between Australia and the, Asia, then we have the Pacific Ocean, and below the Indian landmass, Eurasian landmass, we have the Indian Ocean. A part of the sea that remained in the North Pole area is called as the North Sea. So, and in the south, we have the Antarctic Sea, Northern Ocean, and the Antarctic Ocean. So, like this, we have the five major oceans and the continents also. And exploring about the ocean, because ocean has always been a mysterious thing for the people right from the ancient days. The people always have started knowing about what is there inside the ocean. There has been a curiosity among the scientists, philosophers, writers uh, during the ancient and classical times. So there has been reference to this ocean as being described as the source of mysteries. So some place of living of the demons, or the place where you will be likely to be lost because there is unlimited amount of water to which you cannot come back. So like this, the old classical literatures have tried to define and speak about the oceans just like that. It is something which is invincible, something it is inconceivable, something that it is intradable. That means you cannot explore that. So this is what are the kind of science that has developed in the ancient classical times with the fear of getting into the ocean, that you may not thrive or sustain yourself because there are very large animals which you cannot sustain them. So like this, there has been different type of classical literatures which explains that is also there in your study material. This will be gradually knowing, but in course of time, coming back to about 5000 BC, people started looking into the oceans and describing the oceans in different literatures, right from our Vedas to ancient classical literatures of the European nations. The people have started writing, narrating about the oceans in different forms and different ways, and then gradually coming towards people started moving using boats and then started exploring into the sea. what is there inside. And when they got into the sea through the waves, boats, and then started collecting information, then gradually the uh, information came from the sailors and the boatsmen that yes, it is possible that you can travel, you can cross, you can move, and then you can explore what is there inside, and you can look into the depth also. And in course of time, based on that information, slowly the trade routes started coming up. People started moving with different objects, different materials for trading between different countries, and people started developing understanding about the oceans. In the classical literatures, they were explained after their uh, trading process is over. So that is how gradually ocean information gradually got accumulated, and people started making themselves aware of that. Yes, this is possible that we can explore the oceans, and then major sea voyages have come during the since after the AD period between 1000 to 1600 AD. The most probably the major expeditions took place in the world where the people started going into the high seas with huge boats, locally propelled, wind propelled boats, started exploring about the different continents, just like Vasco da Gama coming to India, and then America being discovered by Columbus, and then Amundsen discovering the North Seas, the Northern Oceans, Captain Scott discovering that Australia and the Indian Ocean and those areas. So like this different type of expeditions gradually took place, and which also culminating in the present time also we have expeditions of Dakshin Gangotri is established station of research in Antarctica where the Indian explorations are also going on, and various countries have started exploring the oceans. Various scientific explorations also came up during the 18th and 19th century. That was the major contribution to the knowledge of oceanography. And of that, the most important is the Darwin's expedition and Glomar Challenger's expedition from the Scripps Institute of Oceanography of California. And then there are a few major expeditions which actually gathered a lot of data about the oceans. And when they gathered data about the oceans, it is more about the ocean characteristics, ocean depth, ocean animal, and then ocean currents, and then behavior of the ocean water at different places, like ocean waves, tides, and currents. So, like this, quite a lot of ocean sediments also they started collecting information. So gradually, this particular experimentation started improving over, and now we are able to collect, going deep into the seas and collecting samples also at great depth, and explorations inside the sea are also being taken up. So this is a way in which you can see this echo sounder instruments which are nowadays used for measuring the depth of the oceans. So now you find a lot of scientific ships which are also anchoring at different places in the ocean to collect continuous data also at different places about the change of temperature, change of pressure, change of salinity, and other properties also. So they are trying to study that how the dynamics of the ocean water is also going on. Because we think that is the ocean water is a constant phenomena, but it is not a constant phenomena. It is much more dynamic, like also our wind. Just like wind moves and creates a weather, similarly, water in the ocean also moves and creates a different type of hydrological situation for the countries around it. And there are also response to the volcanic eruption, there are response to the earthquakes, there are response to the different type of species diversity and movements, and response to different types of waves, currents, and tides. So there are many peculiar phenomena which are observed through this anchoring station. So the scientific research that started from exploring the ocean into a non-entity to an entity by the sailors, and then subsequently by the explorers, and subsequently by the scientific explorations of the present day of the 20th and 21st century. So this is how gathering of information started coming up into the body of knowledge in understanding the oceans and the ocean behaviors. So when we are trying to look at this, this is the middle part of the Atlantic Ocean. You can see that the Atlantic Ocean is like this, and in the continental depth, you must have understood that how the jigsaw fitting characteristics is visible on this. So if you take a profile of this section from this particular place to this place in Africa, and there is a cross section of this, you can see this is what is the cross section. And in this cross section, you see that this is the continental margin on the American side, this is the continental margin in the African side, and then gradually you see that the central part there is a hill, and there are hills in this, and this is what we call it as the mid-oceanic ridge. And this is the basin area, the ocean floor, and uh, this is the Gulf basin, this is the North Atlantic basin. So like this, there are depressions over which we find different islands. These are the submerged islands which are deep are available. These are the Caribbean island groups. And here this is Nova Scotia and then the other islands, Norfolk Island. So like this, and here you have this different type of islands along the African west coast. This is the Panama Isthmus and the surrounding island. So like this, people started gathering about the different type of topographic information about the earth surface and the ocean surface. And while observing the ocean depths, they started also looking into the characteristic temperature of the places. And along with the temperature, they collected samples also. So that was a time when a peculiar thing was observed. This mid-oceanic ridge was discovered during the which led to the idea of plate tectonics and ocean floor spreading is because of this. So these were detected as a submerged mountain at the middle of the ocean on both the sides. You find at the middle there is a system of hills, and these hills are parallel to the coastline moving like this. So that is what is an indication of that the countries and separated from this region. And this is the reason where the temperature of the ocean water is very high, and because of the volcanic activities. And this is the reason where if you find the samples of rocks from these areas, you will find the age of the samples of rocks are lesser, and then the age of the samples of rocks on this side and that side are older. So these are the elder rocks, these are younger rocks, the volcanic eruption, formation of lava and all this, and gradually spreading on either side. And the magnetic property of these rocks also was indicating a different type of polarization, North Pole, South Pole. So all these properties led to the gradual idea that sea floors are spreading. These sea floors are spreading wherever there is a mid-oceanic ridge where the volcanic eruption takes place, and lava comes onto the top, gradually gets deposited on either side, then spreads on both the sides, pushes the oceanic crust towards this area, and along with that also gradually, because these continents are over the oceanic plate. Here the oceanic plate is exposed because there is no continent. But here the oceanic plate is there below the continent, and the continent is just on this. So this is what is a conveyor belt. So this conveyor belt carries this, and these are the islands, the continents which are moving like objects moving on the conveyor belt system. So these gradually led to the configuration of the present configuration, distribution of seas, distribution of small water bodies, bays, then straits, and so many other features that we see on the Earth's surface related to the ocean are a product of this particular process. So you can look at this. This is what is the Atlantic Ocean, where you find this is the Greenland. This is Canadian island system. This is Falkland Island, and then this is Norfolk Bay, and then this is Labrador Peninsula, and this is our northern sea is coming over here. This is the Atlantic Ocean. You see this the submerged mid-Atlantic ridge. Similarly, there are regions here in this side in the Pacific Ocean. There are there are no mid-oceanic ridges in the Pacific, but there is a ridge which is extending like this into the Antarctica, south of this Australian, uh, the Southeast Peninsula. And similarly, in the Indian Ocean also you find a number of ridges. These are the ridges over which you find a number of islands. So like this, there are cracks, there are depressions, there are faults across which the continents are moving apart each other. And that's what was the idea of ocean floor spreading, which ultimately uh, brought the theory into a final shape of building the concept into a plate tectonics theory. So this is the hydrosphere, where that how this ocean water comes up. So in the principal components which are dissolved in seawater, if you look to the chemistry of the seawater, the chloride percentage is 55%, sodium percentage is 30%. So sodium chloride comprises about 85% of the total dissolved materials. Then sulfates 7.68%, magnesium 3.69%, calcium 1.16, potassium 1.1, bicarbonates zero point 0.4, bromides 0.19, borates, and then strontiums. Like this, there are other compounds which are also there. So now we can imagine just like our earth containing nitrogen and then oxygen and carbon dioxide. Similarly, here also you find this maximum amount is chloride and then sodium. So the sodium chloride is the most important content of, and that is what we are exploring as salt. That we are eating it by desiccating the seawater. And within the ocean also we have a large number of trenches, so which are the boundaries between the continental plate and the oceanic plate, where the oceanic plate is continental plates are diverging into the sea. Aleutian Trench, Kuril Trench, Japanese Trench, Mariana Trench, Philippines Trench. So like this, we have so many trenches. You can look at this. This is what is. If you look at this, this is what is Kuril Trench. Then this is Japanese Trench. Then this is Mindanao Trench. This is Philippines Trench. This is this is Mindanao Trench. The Philippines Trench. This is Mindanao Trench. And like this in the Pacific, there this is on this side is California Trench, on this side is Andes Fault, and on this side to the East Australian Trench. So like this, we have trenches across, and on this side is there are you don't find trenches over here because the mid-oceanic ridges are there on this side. You don't have uh, many trenches on this in the Atlantic. So there are few. One most important is Puerto Rico Trench near this West Indian island. To the south of this Bermuda Triangle that we say. This is the place of Bermuda Triangle. South of this is the Puerto Rico Trench. And there are a few trenches also over here. Here it is the Sunda Trench from where the 2004 tsunami took place by the earthquake. And then we have other trenches also at different places. So like this, we have in the world find very peculiar features which are Peru Chile Trench, South Sandwich Trench, Puerto Rico Trench, in the Indian Ocean, the Sunda Trench of the Java Trench, so like this. And the highest depth of the trench is, this is one that is Mariana Trench, that is 10,915 meters. That means almost near about 11 kilometers depth, whereas our Himalaya is about 8 kilometer height. That means you can imagine that even Himalaya with the Everest can be submerged inside this Mariana Trench. So this is what is the kind of depth that so the diversity of the ocean is much more than the diversity of the land. Land is 30%, ocean is 70%. So the diversity in the 70% is likely to be much more than what the land possesses. And average surface temperature, if you go to record just theoretically, in this latitude, 70 to 60-degree latitude, the oceanic temperature is 5.6 degrees Celsius. They are in the north. 60 to 50 degree 8.66, 50 to 40 degree 13.16, 40 to 30 degree 20.4, 30 to 20 we have 24 degree. So this is where we are. 10 to 20 degree it is 25. So Indian Bay of Bengal Arabian Sea remains in this zone. So that is the average temperature is about 25 degree. And to form a cyclone, we need about more than 26, 25 degree or 26 degrees. So that is why very quickly it picks up a situation favorable for the formation of the origin of cyclones because of this. But in the equatorial area, this temperature is very high, but the horizontal force is not 0, and the vertical force is more. So that is the reason for which the wind circulation do not happen, because ultimately whatever the low pressure takes place, that immediately takes up the air from the surface to the upper atmosphere and formation of clouds and thunderstorms. So there is no scope for the cyclone to revolve around the low pressure and the low pressure to continue for a period of time to build into a cyclone. Then yeah, this is what is the situation of the northern hemisphere. In southern hemisphere, you have a little more cooler, because 70-60 degree it is 1.3, minus 60 to 50 degree 1.76. So you can find the northern hemisphere and southern hemisphere temperature differences are so much. Now you can see the graph we are trying to show you. Here it is the depth of water, and then this is the temperature of water, and this is the density line. So this is called thermocline. So at 4,000 depth, 4,000 meter depth, you find it is about 40 degree temperature, 40 degree Fahrenheit. And this 40 degree Fahrenheit temperature gradually with decreasing height, the temperature gradually increases more towards this. The depth is 0 feet, means on the surface. So on the surface temperature is very high, and gradually with increasing depth, the temperature goes on declining, very steep declining within 200 meters. Beyond 200 meters, there is a slow decline up to 800 meters, and beyond 800 meters or 1 kilometer approximately, there is a sharp, quick decline of the temperature. So this is how the ocean depth behaves with respect to the change in the temperature situation inside the ocean. So you can imagine now there are different types of species who will thrive at this temperature. They will live in this zone. Other species who will be comfortable in this temperature, they will live in this zone, and those who will be in this temperature, they will also live here. So they will not come over to this, or these species will not come over to this zone because of their adaptation to the natural temperature situations. So this is how the increasing temperature decreasing from the ocean surface to the depth of about 1200 meters. Similarly, increase in density gradually also takes place. So there is an increase in density along with this. So density increases, temperature decreases. So this is what is the relationship of water in the ocean. And the wave and underground water motion, this water also constantly always in motion. So what happens? The water tends to move on the surface like this through the crest and troughs, crest and troughs. This is the way in which the ocean water moves from the far off inside the sea towards the coast. But the very process of movement is the waves, when they start moving, they don't shift the water from a particular place to the another place. So you can see that water is rising at a particular height, and the crest is formed, and then the same water again falls down, and the crest again becomes low, and the this trough again becomes a crest. So this is one cycle. In the second cycle, the troughs will be the crests, or the same thing will be the, this will be the trough and this will be the crest. So this is what is a kind of process. The same place the waves used to actually reach the water to the top and then again fall down, and pushes the neighboring water to again rise and fall. So this pushing of the process don't carry the water. They actually lift the water to a particular place in the same uh, location, rises and then falls. This is how the stress is created and the water goes on up to the coastline. But the last wave which reaches to the coastline, that is a breaker wave, when the wave starts plunging towards the land and breaks. So that is what is called as breaker wave. That is the last wave. So that last wave actually pushes the water towards the shore and towards the beach. So that is what is called as backwash, and when it returns back, it creates a backwash effect. Forewash and backwash. When the water is rushing in from the form of froth and water just hitting at the coast and then rushing towards the beach is a front wash, and then when it recedes back, it is called as a backwash. So the last wave it is doing like this. Because all other waves they go on just lifting the water, falling the water, lifting the water, falling the water. This is the process. But we normally see as if the wave is bringing water from one place to the other. It is not bringing water. It is rising of water at the same place. So there are theories to explain also that how why this is happening and what are those things which will be we'll see to your study material what is there and accordingly we will discuss those. So this is what is the phenomenon. So in the deep sea there is a huge wave of and the wave is more than kilometer, 5 kilometer, 10 kilometer width of water body will be rising and then it will be slowly falling. And that is what is called the swell waves. That is deep inside the high seas. Or areas where there is uninterrupted flow of air that pushes water to rise. So normal this happens in the southern oceans where there is no land and absolutely water is there. With the northern hemisphere, you find the land is penetrating into the oceans, like India penetrating, dividing the Indian Ocean to Bay of Bengal, Arabian Sea. And then the Middle East also there are many such inlets. In the Southeast Asian region also there are many islands. So the continuity is broken. But if you go to the southern hemisphere, you look at between Australia and then Africa. There is a huge water body without any land mass. There is a huge water body between the South America and Africa. This is a huge water body. There is no interruption in between. So these are the areas where you will find the swell waves. Waves are hundreds at times also it is more than 50-60 kilometers width. A wave is normally what is that? Between two waves there is a wavelength and there are two crests. Between the two crests that is the wavelength. And this wavelength is that we see 5 to 10 meters here along the coast. But if you go to the high seas, it may go beyond kilometers to several kilometers. So you can imagine how the water will be rising and falling in such huge amount. And the last one is the plunging wave that you see. That the last wave, the breaker wave, which falls like this and creates a surfing effect. And the surfing effect takes the water to the shore area and then comes back as a backwash. And while coming to, as a backwash, sometimes this creates a rip current. And this rip current is a very uh, invisible current that operates below the surface of the water at the coastline, where people are at times dragged by this rip current to the deeper oceans. Even if the water is less, they fell down over here. So what happens when the rip current is picking up somebody and the leg is not stable over here and is dislocated from the sea surface here, and all of a sudden he will fall down. Although height of the water may not be 5 feet or 6 feet, maybe 2-3 feet, but he will fall down and immediately he will be dragged inside. So that is how the casualty takes place in the rip currents. And these are mostly taken up by these plunging waves, returning currents. That is what is we call it as rip currents. So this is how we are. Tsunami waves are produced, which are something different from the normal waves. But in tsunami wave, what happens? The water is pushed from one region to the other, and then gradually the force is against the slope. The water starts rising. At this point, it is low, went high, then this high, more high, and reaching to the coast. This is the highest wave that is attacking to the coast. So a normal wave and a tsunami wave, there is a lot of difference. So that is the reason for which tsunami wave creates more destruction than a normal wave. This is the earthquake of 2004 in the, along the Sunda Trench, and then how the water started moving in a circle like a when you throw a water into a pond, you see the ripples are moving towards the shore. Similarly, here also the water after the earthquake, there was a sliding of the plate to about uh, more than 6 feet of water. There has been subsidence of the plate, and because of the subsidence of the plate, there is a sudden change in the water level, and that actually creates a wave, and that wave starts propagating like this, and has created havoc in the 2004. The undersea volcanic activities also are going on constantly at various places. To which we have got volcanic islands, volcanic lava cools, and along with the ocean what knows the wind, there has been also movement of ocean water. Because in the northern hemisphere you have the trade wind will push the water in the northern hemisphere towards, because north, south, northeast trade will be moving like this, so it will be pushing the water towards this side. And then at this point, when it will find a land, there is no space for it to cross onto this side, then the water will be pushed towards the north. And then will be cold water also coming from these polar areas, they will be mixing at this point. The warm water and cold water will mix over here. There will be formation of a lot of fog, a lot of other disturbances, but the water will remain relatively warmer than the surrounding temperature of the area. And that's how it is called as a warm current. The temperature is here on an average 5 to 10-degree difference depending on the place than the normal water. So whatever the temperature is here, the current which will be bringing water, that water will be about 5 to 10-degree higher in temperature, and this 5 to 10-degree higher temperature will gradually decrease towards the north. And while decreasing towards the north, the temperature what will remain over here is more than the minus temperature of these areas. So that is how it remains as a warm current even in this. And because of that slow temperature increase, the coastlines of this side are normally remaining ice free at times. Because of this warm water on this side also the warm water is going. Here also the warm water is coming. Here also this warm water coming up to this, making the ice free in these areas. So like this, there are different type of movements which we will try to know at times. And then we have the tides, the phenomena of movement of water, which is rise and fall of water, and then movement towards the shoreline because of the celestial force, because of the attraction, gravitational pull of the moon, gravitational pull of the sun. There is a force exerted on the water bodies. Water molecules are not so compact like the land molecules. The soil molecules are the atmospheric molecules. So they are a little fragile. So that is the reason for which there is a mobility that comes up with the, just like wind is still mobile, water is less than that, land is completely compact. And these water molecules respond to rise and fall with the attractive force. And this rise and fall that is observed at the coast, so we call it as a tide. And this tidal phenomena is very much related to the earth and the sun and its movement, which is continuously going on. So there is a normally what happens every day there is a time when there is a high tide and then there is a low tide. And every 6 hours there is a tide coming and going back. Every 6 hours there is a tide going and coming back because of the cycling movement of the moon and the sun and their positional changes. So the force of attraction neutralizes, and then once upon a time they join together. Force is relatively more, high tide is formed. When they are segregated from each other in one direction, there are the force is becoming relatively less. That is the time when the low tide comes up. Again, they will come to a conjunction position when there will be high tide. So during the daytime, every 6 hour interval, there is a daytime high tide and a low tide, and during the day, the highest tide is called as spring tide and nip tide. The lowest tide is called as the nip tide. So when there is a continuous record for a month and for a year, every day, morning and evening, so there is a tide gauge reading meter which is placed at the coast, which will observe how much of water rise has taken place. So that from the normal, that is what is called the average tide of that particular place. And if you look to that situation in Orissa coast, we have mm, near about 1 meter of tidal height at Gopalpur port, and which is coming up to more than 2 meter height at Paradip. and slightly more than 2 meters at Baleswar, Digha, and all those places. So gradually the tidal height of the water increases towards the north. Why? The reason is on Bay of Bengal is between two land masses. On India on one side, Burma on the other side, the water is pushed between the two land masses. So this pushing force actually allows the water to rise. Because there are two landmasses, the water cannot go anywhere. So ultimately it has to rise. And then uh, the last point of the Bay of Bengal is Hooghly River. So that is the place where the tide is the highest, 7 to 8 meters. 7 to 8 meters. That means almost it is 25 feet. And that is the time when the highest tide occurs in the Hooghly. The ships in the Hooghly port enters into the harbor. Otherwise, they will remain in the high sea. They will wait up to the high tide. And once the high tide comes, they will get the signal of that and then they will enter into the port. And when again the high tide will come, they will go out of the port. So this is what is the cyclic process in which the ships enter into in tidal ports. Okay, so tidal has many implications, currents has many implications. So we have different type of functions which are related to the earth, human activities also to some extent. So you will be gradually knowing all these things. This is the pull and push factor of the earth and the moon and the formations. Then and this is the kind of distribution of species. And you see, you will find a lot of biodiversity in this zone because here you find a lot of phytoplanktons. To eat the phytoplankton, there will be a lot of small fishes and other animal on species. And then to eat those again, there will be large fishes. So like this, there is a large ecosystem of varieties of species living in this uh, euphotic zone. This is called the euphotic zone. That means zone up to which the sunlight penetrates. And this is what is euphotic zone, and this is an photic zone. And photic zone is sorry, this is photic zone, and this is euphotic zone. So that is what is the basic difference between this and the species distributions. So here you find there are floating species like planktons, diatoms. They are floating. They don't have their own movement. They move with the water. Microscopic algae and microscopic diatoms, species of animals. So they are so like this. We have varieties of sea urchins, cephalopods, gastropods. Varieties of species are there, which are seahorses and like this you will find sea urchins. Varieties there are go on listing will be numerous, more than the land. And at the floor of the ocean also you don't have light, but there are some species which thrive in this dark region, which are called as bentho species. So this is how the distribution of species takes place. You are also supposed to know because based on this species distribution and their decomposition after their death, these materials are deposited into the floor as sediments, chemical sediments, because ultimately there are a lot of calcium and a lot of other minerals which are there with their skeletons, which will be dissolving into the sea and water and then fall into this and create a kind of mud. And this mud is being classified into different types depending on what is the type of composition of these fishes. So there are calcareous species, there are siliceous species, and accordingly there are and then green species of plants, phytoplanktons. So depending on their enrichment of decomposition, this ocean floor is also composed of different types of mud. Green mud, blue mud, yellow mud, red mud, like this, by color. By composition, if you say they are called as those who are close to the continental shelf, they are called as mud. But those who are which are there deep inside the ocean, they are called as ooze. There is a peculiar word used for that. That is WOZE, ooze. So these are the ooze of different type of chemical, very fine chemical particles, mm, like clay, ultimately. Mm, and there are depending on the enrichment of the particular species, they have been named as calcareous ooze, siliceous ooze, and theropods. Like this there are different varieties of species, so that we will also know gradually through our Then there is another interesting thing that takes place in the sea, that is the volcanic eruptions and formation of lagoons or formation of geysers or formation of large volcanic plateaus inside. This is the permafrost region of the North Pole. You can see this, but the present day status is gradually becoming deplorable because the ice mass has started melting in the North Pole at a faster rate than any other place on the Earth. And probably people are thinking of there is no place for the polar bear to live in the ice. This is what is the situation. This is the Greenland ice cover, which is also started melting now. And this is part of Antarctica. This is Greenland, this is Antarctica, which contains about 25 to 30% of the water in these two ice sheets only of the Earth's surface. Ice is North Polar coverage. So during the ice age, wherever the ice age takes place, you can see that the polar ice is extending much deeper inside the land. So if you can think of in Orissa also, in India also, there's up to Talcher area and up to Angul area, which was a part of Africa at that time when there was no movement of continents and the ice age was there. The ice was extending up to this part. So entire peninsular India was under the ice sheets during those times. But gradually it has now come out of that. And this is the ice limit of those times in North America. So you can imagine that entire Canada has been under the ice sheets. Ice age is sea level change due to ice age and ice capping. So now gradually the coastline is changing and then sea level is rising and land is getting submerged into the sea, and somewhere there are submersion, somewhere there are coastal erosion, somewhere there are coastal flooding, somewhere there are uh, coastal submergence. So all these phenomena which are taking place along the coast is mostly because of the climate change that is contributing towards this melting of ice and then movement of extra water in the oceans. There are different types of satellites are now being placed to observe the ocean, because ocean observation is something more critical than the land observation. Um, so there have been different satellites which are being placed to observe what is the temperature over the earth surface, ocean surface, what is the pressure at the ocean surface, what is the salinity of the ocean surface, what are the movement of the ocean surface. Like this, there are satellites which are trying to now monitor all these phenomena of the oceans. Now, this is where we are just having a background to the subject of oceanography, where you know everything from A to Z of what we are going to study. So, in your units, if I go with the subjects that is being given to you, there are two blocks have been given to you. Block 1 is having 3 units, block 2 is having 4 units. Okay, in these 3 units, you don't have much of important topics except origin of the oceans and the origin of ocean water. There are different theories of explanation to the origin of the earth and the oceans is a major component. And then subsequently, what is about what is the composition of the average composition, what is the average temperature distribution, like this. There are some of the common topics. The historical background to the study of oceanography from different people across the globe through the ancient literatures, that is also there to some extent. So not much of things, but there are a few historical development of oceanography as a paper of study in geography at different places. And subsequently, you have also this ocean water properties, physical properties of ocean water, chemical properties of ocean water, composition of ocean water. So these are some of the topics which are there in your unit 1. And in unit 2, you have the waves and tides, you have the ocean sediments, distribution of species of fishes and other biodiversity features. And there are also important theories relating to the formation of coral reefs. This coral reef is a unique feature of the ocean. That is there in your second block in the fourth unit. You will find distribution of coral reefs. Because distribution of coral reefs is a very important indicator of climate change for the Earth's surface. Coral reefs used to grow in a temperature of above 25 degrees Celsius in the ocean waters. So wherever they live, the temperature should be congenial for them if it is beyond 25 degrees. Below 25 degrees, the coral reefs cannot thrive, cannot live. They will die out. So when in the past, when there was the situation prevailing, the coral reefs have developed across the globe. But at the moment, if you look to those coral reefs, they are found in the cold water areas. So that becomes a very important evidence for us that how these coral reefs could be found in the cold water below 25 degrees Celsius. So that is becoming one of the important evidences of climate change. That means the climate has changed for those areas where because coral reefs are not migratory. They have migrated only when the continent is shifting or the ocean floor is shifting. So like the coal deposits across the globe, similarly the coral deposits across the ocean also indicates that the Earth has changed its climate, and the areas where the coral reefs were there, those areas were once upon a time having tropical climate with a temperature above 25 degrees Celsius, and now those areas have now come down to a climatic zone which the temperature is less than 25 degrees. So that itself indicates that either the place has changed or the climate has changed. So over the globe, these two phenomena are likely to happen. So obviously, it implies that the places have changed because of the movement of the continents, because of the plate tectonics. So from the tropical zone, the coral reefs have now come over to this because of the shifting of the landmass. The coral reefs have come to the cold zone. So there are theories of origin relating to the coral reefs. There are different theories to explain how coral reefs are formed, where coral reefs are formed, what conditions are favorable, how they are growing, and then what is the basic presumption behind those. So those things are also a part of our study in the subsequent classes. So we have a background to all these things. Mm. So anything I would like to know from all of you that what are the topics of basic importance that you want to know a little more in details, because we will have two more classes, 2 to 3 classes more tomorrow and day after tomorrow. So accordingly, I will pick up some of those which are relatively more important for your understanding. Because there are certain things which you can historical background, origin of the ocean theories. I think you can understand those because of the reading. There are areas where you may find little difficulty in understanding the waves, understanding the tides, understanding the coral reef distribution and theories, understanding this what we call as seafloor spreading and phylomagnetism. There are certain areas where you find a lot of. I don't find. Are you confined to only two blocks, or there are other blocks also? Because I just looked into that. I found only two blocks are there. Have you got the study materials of oceanography? Anybody who can respond from the other side?
ना सर
स्टडी मटेरियल किसी
No, have you got the study materials of oceanography?
स्टडी मटेरियल तो किसी आसुनी केवल पीडीएफ दीटा अपलोड हेतला से गुडा को
दीटा माने जो ब्लॉक 1 ब्लॉक 2
आज्ञा सर
अच्छा मत कहीं लागुनी सब जगह कोर्स ता भीतर कवर होला भला कुछ थिला भला लागुची काहे ना ता भीतर ओशन करेंट्स नाही आ केतोटे टॉपिक भी नाही ता भीतर तेणु मते लागुची बोते आ गोटे दिटा ब्लॉक कोन रहि जाइछ बोते बुझिबा देखिबा विल सी तकर मटेरियल रेडी नथिबो कि कोन हेतिबो मु जाननी बट एट द मोमेंट तमर तो दिटा ब्लॉक अछि हम से दिटा ब्लॉक विषय डिटेल डिस्कशन करिवा तेणु तमरो जहाँ देखिथिबो जदि से दिटा ब्लॉक भीतर को टॉपिक जाके तुमको बेसी इंपोर्टेंट लागुची को वेयर यू नीड ए मोर ऑफ अंडरस्टैंडिंग so in the next class we will accordingly go with that आज ही हमें जहाँ जहाँ डिस्कशन कले अबाउट द कंपोजिशन ऑफ द ओशन वाटर formation of the ମାନେ ପ୍ରଥମରୁ ଯଦି ଯିବା we discuss something about ମାନେ ଏଇ ଜିନିଷ ଯାକ ଅଛି ତମର content ଭିତରେ theories of origin of the earth accordingly also origin of the oceans ତାପରେ ଆସୁଛି theory of origin of ocean water ତାପରେ ଆସୁଛି physical and chemical characteristics of the ocean water physical characteristics ଭିତରେ ଯାଉଛି temperature physical ଭିତରେ ଯାଉଛି distribution movement of ocean water ତାପରେ the ocean floor and its configuration ଏଇ ଜିନିଷ ଯାକ ଯାଉଛି and all other phenomena associated with the ocean floor chemical characteristics ଭିତରେ ଯାଉଛି temperature pressure density salinity their distribution across the different globes ଏଇ ଜିନିଷ ଯାଉଛି ତାପରେ we are trying to study about the relief of the ocean bottoms Pacific Ocean Atlantic Ocean ଆଉ Indian Ocean ଭିତରେ କ'ଣ difference ରହିଛି in the ocean floor characteristics କୋଉଠି କ'ଣ ରହିଛି କୋଉଠି submerged କୋଉଠି mountains କୋଉଠି islands କୋଉଠି ridges କୋଉଠି volcanoes କୋଉଠି island arcs କୋଉଠି trenches କୋଉଠି mouths କୋଉଠି basins ଏମିତି ବହୁତ ଗୋଟେ ଜିନିଷ ରହିଛି ocean ଭିତରେ ସେଇ ଯାକ ଗୋଟେ aspect that is what we call it as the bottom relief of the ocean floors ତାପରେ ଆଉ ଗୋଟେ important topic ରହିଛି that is distribution of sediments across the ocean sediments ରେ ଆମର ଗୋଟେ ହେଲା land origin sediments ଆଉ ଗୋଟେ ହେଲା sea origin sediments land origin sediment को ଆମେ terrigenous sediments କହୁଛେ ocean origin sediment को ଆମେ କହୁଛେ pelagic sediments ତେଣୁ land origin sediment ଯାକ mostly coast ରେ ଥାଏ coast line ରେ ଥାଏ close to the continental shelf ଭିତରେ ଯାଇକି ଥାଏ କିଛି river ଯାଇକି deposit ହେଇଥାଏ wind ରେ ଯାଇକି deposit ହେଇଥାଏ ଯାକ ହେଲା land origin sediments along the coast ତାପରେ sea origin sediments ରେ ଆମର ରହିଛି sea mud ହଉଛି ଗୋଟେ ଜିନିଷ important then sea oozes ରହିଛି ଆଉ ଗୋଟେ red clay ଏମିତି ତିନି ପ୍ରକାର sediment ରହିଛି mud ଯୋଉଟାକି କି ଆମର close to the continental slope and the continental shelf from margin last part of the continental shelf ଆଉ slope ରେ ଯୋଉଟାକ develop ହୁଏ these are called sea mud ଯୋଉଟାକି କି ଆମର tide ଯେତେବେଳେ ଆସେ ନଈ ମୁହାଣ ଭିତରକୁ ଆସିକି ନଈ ମୁହାଣ ଜାଗାରେ କାଦୁଅ କରେ ଯୋଉଟାକ ଆସିକି that is what is sea mud ଯାକ much deep inside the ocean deep ocean floor ରେ ଯାକ ରହିଛି pelagic abyssal plains ରେ ଯାକ ହଉଛି that decomposed to chemical materials of the dissolved skeletons and other body parts of the plants and animals living inside the sea they create a kind of chemical mud that chemical mud is called as ooze ଯୋଉଥିରେ କି physical ଜିନିଷ କିଛି ମିଶି ନଥାଏ ବାହାର ଜିନିଷ କିଛି ମିଶି ନଥାଏ sand silt clay ଯାକ କିଛି ମିଶି ନଥାଏ they are chemical residues ସେ ଯାକ କହନ୍ତି ooze ବୋଲି ସେ ooze ର ତିନି ଚାରି ପ୍ରକାର କ୍ଲାସିଫିକେସନ ଅଛି depending on which species are dominating in that ooze କାରଣ ସେଇ species ର ସେଇ particular characteristics ଥାଏ ସେ ଅନୁସାରେ କଲର ବି ତାର ଡିଫରେନ୍ସ ହେଇଥାଏ ଆଉ ତାର ବିହେଭିୟର ବି ଡିଫରେଣ୍ଟ ହେଇଥାଏ material behavior ଟିକେ different ହୁଏ and they have tried to classify this based on the samples collected from the sea floor as siliceous ooze ଆଉ ତାପରେ ଗୋଟେ ହେଲା calcareous ooze siliceous ooze ଭିତରେ ଦି ତିନି ପ୍ରକାର ରହିଛି calcareous ooze ଭିତରେ ଦି ତିନି ପ୍ରକାର ରହିଛି depending on the dominance of the species ତେଣୁ ଇଏ ଗଲା ତାପରେ sea sediments distribution relief distribution sediment distribution ତାପରେ ରହିଛି ocean coral reef distribution and theories of origin of the coral reef ତାପରେ ଆଉ ଗୋଟେ phenomena ରହିଛି ଆମର important phenomena understanding of the waves and tides and the theories of origin of the waves and theories of origin of the tides ତାପରେ ଆଉ ଗୋଟେ ପାର୍ଟ ରହିଛି ocean currents କିନ୍ତୁ ମୁଁ କାଇଁ ଦେଖିଲିନି କୋଉଠି ତମର material ଭିତରେ ଦିଟା ବ୍ଲକ ଭିତରେ ocean currents ନାହିଁ ମତେ ଲାଗୁଛି ବୋଧେ ସେଟା ନିଶ୍ଚିତ ଥିବା କଥା ରହିନି କାହିଁକି ଜାଣି କିନ୍ତୁ ଆଉ ଗୋଟେ ବ୍ଲକ ଯଦି ଥିବ ଛାଡି ଯାଇଥିବ ଆସିନଥିବ material upload ହେଇନଥିବ ତାହେଲେ ଥିବ ସେଥିରେ that may be there that is ocean currents ତ ଏମିତି କିଛିଟା important ଜିନିଷ ରହିଛି but content is relatively less in comparison to other papers ଅନ୍ୟ paper ଅପେକ୍ଷା ୟାର content ଟିକେ କମ ହବ but these are some of the important topics of relevance for you in understanding
सर ओशन करंट बोधे ब्लॉक 4 रे
ଶୁଭୁନି ଆଉ ଥରେ କହିଲ ଟିକେ
सर ओशन करंट ब्लॉक 4 रे बोधे सेटा अछि
ବ୍ଲକ 4 ରେ ବ୍ଲକ 3 ଆଉ 4 ତ ନାହିଁ ଆମ ପାଖରେ ଅଛି କି?
ସାର୍ ନାହିଁ ସେଇ ପିଡିଏଫଟା ଟିକେ ମାନେ ଅଛି 4ଟା ବ୍ଲକର ଟିକେ ଟିକେ ଅଛି
ହଁ
ସେଇଟା।
ସେ ମାନେ ରହିଯାଇଛି 3-4 ବ୍ଲକ ରହିଯାଇଛି ତା ଭିତରେ ଆଉ କିଛି କିଛି ଅଛି। ତାକୁ ଦେଖିବା ଆମେ ତାକୁ
ଅଛି
ବୁଝିବାକୁ ଚେଷ୍ଟା
ସାର୍।
କରିବା।
ସାର୍ ବ୍ଲକ 3ଟାରେ ସାର୍ ବୋଧେ ଅଛି ଆମର ପ୍ରପର୍ଟିଜ ଅଫ ଓସେନ, ସେଥିରେ ଓସେନ ଟେମ୍ପରେଚର, ସାଲିନିଟି ଆଉ ଡେନ୍ସିଟି ଅଛି।
ହୁଁ
ଆଉ ବ୍ଲକ 4ଟାରେ ଅଛି ଆମର ଓସେନ ସର୍କୁଲେସନ ଆଣ୍ଡ କଣ୍ଟେମ୍ପୋରାରୀ ଇସ୍ୟୁଜଟା। ସେଇଥିରେ ଅଛି
ଆଚ୍ଛା
ଓସେନ ୱେଷ୍ଟ ସାଇଡ, ଓସେନ କରେଣ୍ଟ ଅଛି, ଆଉ ଅଛି ଇମ୍ପାକ୍ଟ ଅଫ ଗ୍ଲୋବାଲ ୱାର୍ମିଂ ଅନ ଓସେନ, ତାପରେ ଅଛି ଏକ୍ସକ୍ଲୁସିଭ ଇକୋନୋମିକ ଜୋନ ଆଣ୍ଡ କୋଷ୍ଟାଲ ରେଗୁଲେସନ।
ହୁଁ ଠିକ ଅଛି ଆଉ ଓକେ। ତେଣୁ ଏଇ ସବୁ ଜିନିଷ ଅଛି ତେଣୁ ତମର ସବୁ ଜିନିଷରେ ଯଦି ଟିକେ ଟିକେ ଜାଣିବା ଦରକାର ୱିଲ୍ ଡିସ୍କସ୍ ଆକର୍ଡିଂଲି ଆଣ୍ଡ ଗୋ। ଆମେ କାଲିକି ଆଜି ଯୋଉ ଯାକ ଡିସ୍କସ୍ କଲେ ମୋଷ୍ଟଲି ବ୍ଲକ 1 ର ଜିନିଷ ଗଲା। କାଲିକି ବ୍ଲକ 2 ର ଜିନିଷ 4 ୟୁନିଟ୍ ଭିତରେ ଦେଖିବା। ତାପରେ 3-4 ଦେଖିବା ଆଉ ୱିଲ୍ ସି ଟୁ ଦ୍ୟାଟ୍। କିନ୍ତୁ ଗୋଟେ ଇମ୍ପୋର୍ଟାଣ୍ଟ ଜିନିଷ ଯଦି ତମେ କିଛି ପଢିକି ଆସିଛ କି ଦେଖିଛ ଯଦି ତାହେଲେ ପଚାରିବା ଦରକାର। ନ ପଚାରିଲେ ଏମିତି ଡିସ୍କସନ ହେଇକି ରହିଯିବ। And you may not be in a position to clarify your doubts. ତେଣୁ କଣ କରିବା କୁହ ତମର what is your feeling and what you want? କେମିତି ଏମିତି ସିଷ୍ଟମାଟିକ ଯିବା ନା ଆଉ କଣ କରିବା? Any response from your side?
ସାର୍ ଏମିତି ହିଁ
ଏମିତି ହିଁ ଯିବା। ବର୍ତ୍ତମାନ ଆମେ ତ ବନ୍ଦ କରିଦେଲି ସ୍ଲାଇଡକୁ। ବର୍ତ୍ତମାନ କଣ କ୍ୱେଶ୍ଚନ ପଚାରିବାର ଅଛି ଟିକେ ପଚାର ଯାହା ବି ତମ ମାଇଣ୍ଡ ଭିତରକୁ ଆସୁଛି that anything you feel like asking.
सर जो ओशियन करेंट एटा सेटा इंडियन मॉनसून को केमती अफेक्ट करे?
ସେଇଟା ଓକେ ଇଣ୍ଡିଆନ ମନସୁନ କୁ କେମିତି ଆଫେକ୍ଟ କରେ କରେଣ୍ଟ? କାହିଁକି ଇଣ୍ଡିଆନ ମନସୁନକୁ ଆଫେକ୍ଟ କରିବାର ସ୍କୋପ ରହିଛି ଯେତେବେଳେ ସାଉଥ ୱେଷ୍ଟ ମନସୁନ ଏଷ୍ଟାବ୍ଲିଶ ହୁଏ ସେତେବେଳେ ଆମର ଓସେନ କରେଣ୍ଟ on the east coast and west coast is movement of warm water from the equatorial region towards north. ତେଣୁ ଆମର ମାନେ ପେନିନସୁଲାର ଇଣ୍ଡିଆ ସାଉଥ ମାନେ କେପ୍ କାମରିନ ପାଖରୁ ଏପଟେ ଗୁଜରାଟ କୋଷ୍ଟ ପର୍ଯ୍ୟନ୍ତ ଏପଟେ ୱେଷ୍ଟ ବେଙ୍ଗଲ କୋଷ୍ଟ ପର୍ଯ୍ୟନ୍ତ ୱାର୍ମ ୱାଟର ତକ ଉପରକୁ ଉଠେ। ତେଣୁ ୱାର୍ମ ୱାଟର ଉପରକୁ ଉଠିଲେ ରିଲେଟିଭଲି ଟେମ୍ପରେଚର 2-3 ଡିଗ୍ରୀ ଯଦି ଡିଫରେନ୍ସ ହେଲା from the surrounding sea water, it is a favorable condition for heating the water on the of the ocean surface and mixing of this heat with the main water bodies, raising the temperature of the ocean surface. Then that contributes towards heat generation in the oceans and contribute towards creation of more moisture. तो बेसी moisture create करिवार scope create करे। तेणु बेसी moisture create हेले अब other ideal conditions रहिले it helps to the formation of the cyclones. And it ହେଲା cyclone ସହିତ ତାର relationship of the monsoon season and the currents. କାହିଁକିନା ଆମର ଯେତେବେଳେ ନର୍ଥ ଇଷ୍ଟ ମନସୁନ ଚାଲିଥାଏ ସେତେବେଳେ କୋଲ୍ଡ ୱାଟର ଫ୍ରମ ଦି ନର୍ଦର୍ନ ପାର୍ଟ ଅଫ ଦି ଏଇ ଯୋଉ ଗୁଜରାଟ ଆଉ ୱେଷ୍ଟ ବେଙ୍ଗଲ ପାଖରୁ ତଳ ଆଡକୁ ବହେ କରେଣ୍ଟ। କିନ୍ତୁ ଯେତେବେଳେ ସାଉଥ ୱେଷ୍ଟ ମନସୁନ ଆସେ ସେତେବେଳେ ସେଇଟା ରିପ୍ଲେସ ହେଇଯାଇକି ୱାର୍ମ ୱାଟର ଫ୍ରମ ଦି ଇକ୍ୱେଟୋରିଆଲ ରିଜନ ଇଜ ମୁଭିଂ ଟୁୱାର୍ଡସ ଦି ନର୍ଥ। ତେଣୁ ଯେତେ ନର୍ଥକୁ ଯିବ ୱାର୍ମ ୱାଟର ଯିବ ସେତେ ପାଣି ସହିତ ମିଶିବ ଟେମ୍ପରେଚର ବଢିବ ଟେମ୍ପରେଚର ବଢିଲେ conditions become ideal for the formation of cloud and moisture. And that way it contributes towards the southwest monsoon and then southwest monsoon contributes towards the formation of cyclones. Okay, ନା ନା ଆଉ କିଛି ଅଛି? Any other doubt? तो आंसर बुझिएला ना नहीं कन
ନାଇଁ ଆଉ ଥରେ ଟିକେ ସିମ୍ପଲ କରି କହିଲେ।
ଏଇଟା କଣ ବେଶୀ ଡିଫିକଲ୍ଟ ଲାଗି ଆମର ଇଣ୍ଡିଆନ ଓସନ ରେ ନର୍ମାଲି ଯେତେବେଳେ ନର୍ଥ ଇଷ୍ଟ ମନସୁନ ଚାଲିଥାଏ ମାନେ ୱିଣ୍ଟର ସିଜନ ସେତିକି ବେଳେ ଆମର ଯୋଉ ଓସନ କରେଣ୍ଟ ଯାକ ଇଣ୍ଡିଆ କୋଷ୍ଟରେ ଥାଏ ସେ କୋଷ୍ଟର କରେଣ୍ଟ ଯାକ ନର୍ଥ ରୁ ସାଉଥ କୁ ଯାଏ ତେଣୁ ସେଇଟାକୁ କହନ୍ତି ନର୍ଥ ଇଷ୍ଟ ଓସନ କରେଣ୍ଟସ୍ ଯୋଉଟାକି କି ଆମର ୱେଷ୍ଟ ବେଙ୍ଗଲ କୋଷ୍ଟ ରୁ କେପ୍ କେମରିନ ମାଡ୍ରାସ ଆଡକୁ ଆସେ କୋଲ୍ଡ କରେଣ୍ଟ ହେଇକି ସେମିତି ସେପଟେ ଗୁଜୁରାଟ କୋଷ୍ଟ ରୁ ତଳକୁ ଆସେ କେପ୍ କେମରିନ କେରଳ ଆଡକୁ ତେଣୁ ଏଇ ଦିଟା ହେଲା ରିଲେଟିଭଲି କୋଲ୍ଡ କରେଣ୍ଟ ଯେମିତି ଆମର କୋଲ୍ଡ ୱେଭ୍ ଯେମିତି ଆସେ ୱିଣ୍ଟର ସିଜନ ଆସିଲେ ଥଣ୍ଡା ପବନ ଆସେନି ଶୀତ ଆସେ ସେମିତି ପାଣିତକ ବି ଆମର ନର୍ଥରେ ବେଶୀ ଥଣ୍ଡା ହୁଏ ସେ ଥଣ୍ଡା ପାଣିତକ ଗ୍ରାଜୁଆଲି ତଳକୁ ସିଫ୍ଟ ହେଇ ଆସେ କିନ୍ତୁ ଯେତେବେଳେ ସମର ସିଜନ ଆସେ ଆମର ସାଉଥ ୱେଷ୍ଟ ମନସୁନ ଯେତେବେଳେ ଡୋମିନେଟ କରେ ସେଇ ସମୟରେ ଦି କରେଣ୍ଟ ଇଜ ରିପ୍ଲେସଡ ବାଇ ଯେମିତି ମନସୁନ ୱିଣ୍ଡ କରେଣ୍ଟ ଇଜ ରିପ୍ଲେସଡ ବାଇ ନର୍ଥ ଇଷ୍ଟ ମନସୁନ ଟା ସାଉଥ ୱେଷ୍ଟ ମନସୁନ ରେ କନଭର୍ଟ ହୁଏ ସେମିତି ଏଇ ଯୋଉ କରେଣ୍ଟ ନର୍ଥ ଇଷ୍ଟ କରେଣ୍ଟ ସେଇଟା ପୁଣି ସାଉଥ ୱେଷ୍ଟ କରେଣ୍ଟ ରେ କନଭର୍ଟ ହୁଏ ସାଉଥ ୱେଷ୍ଟ କରେଣ୍ଟ ରେ କନଭର୍ଟ ହେଇକି ଆମର ଇକ୍ୱେଟୋରିଆଲ ଏରିଆର ଯୋଉ ୱାର୍ମ ୱାଟର ତକ ସେ ଯାକ ପୁସ୍ ହେଇକି କୋଷ୍ଟ କଡ କଡ ଦେଇକି ଯାଏ ତେଣୁ ସେଇ ଯୋଉ କରେଣ୍ଟ ଯାଏ ସେ ଟିକେ ୱାର୍ମର ହେଇକି ଥାଏ ଦେନ୍ ଦି ସରାଉଣ୍ଡିଂ ୱାଟର ଅଫ ଦି ବେ ଅଫ ବେଙ୍ଗଲ ଆଣ୍ଡ ଦି ଆରାବିଆନ ସି ତେଣୁ କୋଷ୍ଟର ଯୋଉ ହିଟ୍ ତକ ଅଧିକା ଥାଏ ଏକୁମୁଲେଟ କରିକି ସେ କରେଣ୍ଟରେ ସେ ଯାକ ଡିସିପେଟ करे ଟୁୱାର୍ଡସ ଦି ମେନ୍ ୱାଟର ବଡିଜ ଆଣ୍ଡ ଇନକ୍ରିଜେସ ଦି ଟେମ୍ପରେଚର ଅଫ ଦି ଓସନ୍ସ ଟେମ୍ପରେଚର ଓସନ ଟେମ୍ପରେଚରକୁ ଟିକେ ବଢାଏ ଯୋଉଥିପାଇଁ କି ଆମର ହିଟିଂ ପ୍ରୋସେସରେ ଟିକେ ଇଜି ହୁଏ ହିଟିଂ ପ୍ରୋସେସ ଇଜି ହେଲେ ଟେମ୍ପରେଚର ରାଇଜ କଲେ 25 ଡିଗ୍ରୀରୁ ଅଧିକା 26 ଡିଗ୍ରୀ ଅଧିକା ହେଲେ ଆଇଡିଆଲ କଣ୍ଡିସନ ହବ ଫର ଦି ଫର୍ମେସନ ଅଫ ଲୋ ପ୍ରେସର ଆଣ୍ଡ ଡେଭଲପମେଣ୍ଟ ଅଫ ଦି ସାଇକ୍ଲୋନ ତେଣୁ ସେଇଥିକୁ କଣ୍ଟ୍ରିବ୍ୟୁଟ କରେ ଏଇ କରେଣ୍ଟ ତେଣୁ ସାଉଥ ୱେଷ୍ଟ ମନସୁନ କରେଣ୍ଟ along the Indian coast contributes more heat to the Arabian Sea and the Bay of Bengal and helps in warming of the ocean water ତେଣୁ ocean water ଯେତେ ଅଧିକା ୱାର୍ମ ହବ ସେତେ ଅଧିକା କ୍ଲାଉଡ ଫର୍ମେସନ ମଏଶ୍ଚର ଫର୍ମେସନ ହବ and if the other ideal conditions are there for the formation of the cyclone then this is going to contribute more towards that and help in the formation of the cyclone ଏଥର ବୁଝିହେଲା
ଆଜ୍ଞା ସାର୍ ଜାଣିଲି।
କରେଣ୍ଟ ଯାକ ସବୁବେଳେ ପବନ ଦ୍ଵାରା ବହେ ତେଣୁ ପବନ ଯୋଉ ଡିରେକ୍ସନ ରେ ହୁଏ କରେଣ୍ଟ ସେଇ ଡିରେକ୍ସନ ରେ ଚାଲେ ତେଣୁ କରେଣ୍ଟ କଣ କି କରେଣ୍ଟ ଇଜ ଏ ମାସ୍ ଅଫ ୱାଟର ମୁଭିଂ ଲାଇକ୍ ଏ ରିଭର ଇନ ଦି ସି ସମୁଦ୍ରର କୌଣସି ଗୋଟେ ଜାଗାରେ କରେଣ୍ଟ ତକ ମୁଭ କରେ ବାଇ ଦି ଫୋର୍ସ ଅଫ ଦି ୱିଣ୍ଡ କାରଣ ଯେତେବେଳେ କନଷ୍ଟାଣ୍ଟଲି ୱିଣ୍ଡ ବହେ ସାଉଥ ୱେଷ୍ଟ ମନସୁନ ଯେତେବେଳେ ଆସେ ଆମର ପବନଟା କୋଉଠୁ ସାଉଥରୁ ଆସେ ସାଉଥରୁ ଆସିଲେ ଯେତେବେଳେ ନର୍ଥ ଆଡକୁ ପବନ ଯାଏ ସେ ପାଣି ତକ ସମୁଦ୍ରର ପ୍ରେସରାଇଜ ହୁଏ ପ୍ରେସରାଇଜ ହେଲେ ଏପଟରେ କୋଷ୍ଟ ଲାଇନ ରହିଗଲା ମଝିରେ ସି ରହିଲା ତେଣୁ ସେ ଭିତରେ ପ୍ରେସରାଇଜ ହେଇକି ଗୋଟେ କଡ ଦେଇକି ସେ କରେଣ୍ଟ ତକ ମୁଭ କରେ ସେଇ କରେଣ୍ଟ ଟାକୁ ଆମେ କହୁ ବେଳେବେଳେ ଲିଟୋରାଲ ଡ୍ରିଫ୍ଟ କରେଣ୍ଟ ବୋଲି ବି ବେଳେବେଳେ କହୁ ଇଣ୍ଡିଆ କୋଷ୍ଟରେ ତେଣୁ ସେ ଲିଟୋରାଲ ଡ୍ରିଫ୍ଟ କରେଣ୍ଟରେ ଦି ପ୍ରକାର ଜିନିଷ ଯାଏ ଗୋଟେ ହେଲା ଆମର ଯେତେ ନଈର ବାଲି ମାଟି ସେ ଯାକ ଆସିଥାଏ ସମୁଦ୍ର ଭିତରକୁ ସେଇ ଯାକ ବି ବୋହି ହେଇକି ଯାଏ ପ୍ଲସ ୱାଟର ବି ଇକ୍ୱେଟୋରିଆଲ ଏରିଆରୁ ବୋହି ହେଇକି ଯାଏ ଆଉ ୱାଟର ଯେତେବେଳେ ଯାଏ ଇକ୍ୱେଟୋରିଆଲ ଏରିଆର ଟେମ୍ପରେଚର ଅଧିକା ଥାଏ ତେଣୁ ସିଏ ଟେମ୍ପରେଚର ବଢି ବଢି ଯାଏ ଟୁୱାର୍ଡସ ଦ ନର୍ଥ ତେଣୁ ଆମର ସାଇକ୍ଲୋନ ଫର୍ମେସନ ପାଇଁ ଯୋଉ ଆଇଡିଆଲ ଟେମ୍ପରେଚର କଣ୍ଡିସନ ଦରକାର ସେଇ କଣ୍ଡିସନକୁ କଣ୍ଟ୍ରିବ୍ୟୁଟ କରେ ଏଇ ଓସେନ କରେଣ୍ଟ ବାଇ ଟ୍ରାନ୍ସଫରିଂ ହିଟ୍ ଫ୍ରମ ଦି ଇକ୍ୱେଟର ଟୁ ଦି tropical zone ବା tropic of cancer zone ଆଉ ୱାଟର ଯୋଉ ମିକ୍ସିଂ ହୁଏ କେମିତି କି ଏମିତି ମିକ୍ସିଂ ହୁଏ ସମୁଦ୍ର ଭିତରେ ଟେମ୍ପରେଚର ଚେଞ୍ଜ ଟେକ୍ସ ପ୍ଲେସ୍
ସାର୍ ତା ମାନେ ଯୋଉ ଅଘୁଲା କରେଣ୍ଟ ସେଇଟା ବହୁତ କଣ୍ଟ୍ରିବ୍ୟୁଟ କରେ।
ଅଗୁଲେସ୍ କରେଣ୍ଟ ତ ଏଠି ଆମର ଇଣ୍ଡିଆନ ଓସନରେ ତ ନାହିଁ ସେଟା କୋଉଠି ଅଛି
ଇଣ୍ଡିଆନ ଓସନ ରେ ତ ଆଫ୍ରିକାନ
କୋଉଠି
ସାଇଡ ରେ ଯାଉଛି
ଆଫ୍ରିକାନ ସାଇଡରେ ଅଛି ନା ଅଗୁଲେସ୍ କରେଣ୍ଟ କୋଉଠୁ କୁଆଡେ ବହେ
ଇଷ୍ଟ ଆଫ୍ରିକାରେ ଅଛି ନା ଯୋଉଟା
ହଁ ଯେ କୋଉଠୁ କୁଆଡକୁ ବହେ ସେ କରେଣ୍ଟ
ସେ ଯୋଉ ଇକ୍ୱେଟର ରୁ ସାଉଥ ୱାର୍ଡ କୁ ତ ବହେ
କୋଉଟା ମାଲାଗାସ ରିପବ୍ଲିକ ମାଡାଗାସ୍କାର ଦେଇକି?
ମାଡାଗାସ୍କର ଦେଇକି ଆଜ୍ଞା।
ହୁଁ ତେଣୁ ସିଏ ବି ସେଇଆ, ତାର ଫେନୋମେନା ବି ସେଇଆ, କାରଣ ସେ ଜାଗାରେ ବି ସାଇକ୍ଲୋନ ହୁଏ ନା। ଟ୍ରପିକାଲ ସାଇକ୍ଲୋନ ମାଡାଗାସ୍କାରରେ ହୁଏନି କି?
ଆଜ୍ଞା।
ହଁ ମାଡାଗାସ୍କାରରେ ହୁଏ, ସାଉଥ ଆଫ୍ରିକାର କିଛି ଏରିଆରେ ହୁଏ, ନର୍ଦର୍ନ ପାର୍ଟରେ, ଆଉ ମାଡାଗାସ୍କାର ସେ ଏରିଆରେ ହୁଏ। ତାପରେ ଏପଟେ ହୁଏ, ଏଇ ଯୋଉ ଓମାନ ଆଉ ସେଇ ପାଖାପାଖି ଏରିଆରେ ହୁଏ ସାଇକ୍ଲୋନ। ତେଣୁ ଏଇ ତାର ଇଫେକ୍ଟ। ହୁଁ ତେଣୁ କରେଣ୍ଟ ହେଲା ଗୋଟେ ମେଜର ସୋର୍ସ ଅଫ ଡିଷ୍ଟ୍ରିବ୍ୟୁସନ ଅଫ ହିଟ୍ ଇନ ଦି ଓସେନ୍ସ। ଓସେନର ହିଟ ର ଇମ୍ବାଲାନ୍ସକୁ ବାଲାନ୍ସ କରିବା ପାଇଁ ଇଏ ଗୋଟେ ଫେନୋମେନା ନ୍ୟାଚୁରାଲି ଚାଲିଛି। So that is the major carrier of heat. ତେଣୁ ହିଟ୍ କ୍ୟାରିୟର ସାଙ୍ଗରେ there is also major carrier of ସ୍ପେସିସ୍, କାହିଁକିନା ସେଇ ଟେମ୍ପରେଚର ଭିତରେ ଯୋଉ ସ୍ପେସିସ୍ ଯାକ ଆଇଡିଆଲ ସେମାନେ ବି ତା ଥରେ ସେଇ ପାଣିରେ ଯାଆନ୍ତି ହାରି, ପ୍ଲେସ୍ ଚେଞ୍ଜ କରନ୍ତି। ତେଣୁ ବାୟୋଡାଇଭର୍ସିଟିର ଚେଞ୍ଜ ବି ସେମିତି ହୁଏ। Okay, any other question? ଆଉ କିଛି ପଚାରିବ? କ୍ୱେଶ୍ଚିନ୍ ପଚାରିବା ପାଇଁ ତମେ ଯଦି ଏତେ ସମୟ ନବ କେମିତି ହବ? ଯେତିକି ଶୁଣିଲ ତା ଭିତରେ ବି ତ କିଛି ଗ୍ରାସ୍ କରୁଥିବ ନା, ତାକୁ ବି ଯଦି କିଛି ନ ବୁଝା ପଡୁଛି ପଚାରୁନ। ଯଦି ବହି ପଢିନ ଠିକ ଅଛି, ନ ପଢି ଆସିଲେ ବି ତମେ ଯାହା ଶୁଣିଲ ତା ଭିତରେ ତ ସେ ପଚାରି ପାରିବ ନା। କଣ୍ଟେଣ୍ଟ ତ ଦେଖିକି ଆସିଥିବ ଟିକେ ଟିକେ, ଟପିକ ର ନାଁ ଅନୁସାରେ ବି କିଛି ପଚାରି ପାରିବ। ୱେଭ୍ସ ଆଉ ଟାଇଡ୍ସ ଭିତରେ ଡିଫରେନ୍ସ କଣ ଜାଣିପାରିଲ? Can any of you tell about what is the difference between wave and tide? ଜଣେ କି କୁହ ତମର, what is the difference between a wave and a tide?
ସେ ଟାଇଡ୍ ଟା ଯୋଉଟା ସେଟା ଗ୍ରାଭିଟେସନାଲ ଫୋର୍ସ ପାଇଁ ହେଇଥାଏ, ସେ ଦିନକୁ 2 ଥର ଆସେ, ହାଇ ଟାଇଡ୍ ଲୋ ଟାଇଡ୍ ହେଇକି। କିନ୍ତୁ ୱେଭ୍ସ ଯୋଉଟା ସେଟା କେବଳ ଟ୍ରାନ୍ସଫର ଅଫ ଏନର୍ଜି ହେଇଥାଏ ଓସେନରେ।
ଫେନୋମେନା କଣ ତାକୁ ଏକ୍ସପ୍ଲେନ କର, ତାପରେ ସେ ଏନର୍ଜି କୁ ଯିବ। କାଇଁ ଟାଇଡ୍ ରେ କଣ ଏନର୍ଜି ଆସୁନି କି? ଟାଇଡ୍ ଅଲସୋ
ମେନଲି ଡ୍ରାଇଭିଂ ଫୋର୍ସ ଯୋଉଟା ସେଟା ହଉଛି ଟାଇଡାଲ ଫୋର୍ସ।
टाइडल फोर्स रे कौन वेव जनरेट हुए? Wave generate हुए because of the wind force, not
ଆଜ୍ଞା।
because of the tidal force.
ନାଇଁ ସେ ଯୋଉ ଟାଇଡ୍ ଟା ଯୋଉଟା ଗ୍ରାଭିଟେସନାଲ ଫୋର୍ସ ପାଇଁ କି ଯୋଉ।
So tide जोटा हुए because of the gravitational force.
ଆଜ୍ଞା।
Tide ର ଯୋଉ amplitude ଯେତିକି height ବଢିବ tide ର, that amplitude is directly proportional to the force exerted by the moon and the sun.
ଆଜ୍ଞା।
କିନ୍ତୁ wave ର କଣ, wave ର ତ ସେଇଆ ନୁହଁ ନା। wave ରେ force କୋଉଠି generate ହୁଏ? It is the force of the wind which is pushing the water against this floor of this ocean. ଯେତେବେଳେ wind ର force ରେ ପାଣି ତକ compress ହୁଏ ଆଉ floor କୁ pressurize କରେ, floor ପର୍ଯ୍ୟନ୍ତ ଯେତେବେଳେ pressurize ହୁଏ, floor ରୁ rebound action ଆସେ and water is lifted. ଯେମିତି ତମେ ଗୋଟେ କୌଣସି ଗୋଟେ ଜିନିଷକୁ ପୁsh କଲେ ସେ ଗୋଟେ ଜିନିଷ ଉପରକୁ ଉଠିବାକୁ ଚେଷ୍ଟା କରିବ। ଯେମିତି ମନେକର ଗୋଟେ ଇଲାଷ୍ଟିକ ସବଷ୍ଟାନ୍ସ ତମେ ରଖିଛ ବା ଗୋଟେ ଇଏ ରଖିଛ, ତମେ ଗୋଟେ ଏଣ୍ଡରୁ ପୁsh କଲେ ସେ କଣ ହବ, ଆଉ ଗୋଟେ ଏଣ୍ଡ ମଝିରେ ସେ ତାର ଉଠିବାକୁ ଚେଷ୍ଟା କରିବ କ୍ରେଷ୍ଟ ହେଇକି। ସେମିତି ପାଣି ତକ ସେମିତି ଗୋଟେ କ୍ରେଷ୍ଟ ହେଇକି ଉଠେ, କ୍ରେଷ୍ଟ ହେଇକି ଉଠେ and then again it falls back to the same position. ତାପରେ ଆଉ ଗୋଟେ କ୍ରେଷ୍ଟ ପୁଣି ଉଠେ, ପୁଣି ସେ ପଡେ। ତେଣୁ ଯେତେବେଳେ ଉଠେ ନେଇବରିଂ ୱାଟର ତକ ଡିସପ୍ଲେସ ହେଇଯାଏ। ତେଣୁ ट्रफ डेवलप करे ट्रफ डेवलप कला पर तार नेबरिंग एरिया रे पुणी क्रेस्ट डेवलप करे so this is a continuous process of rising of the water in the form of crest and the trough एमती कि ग्रेजुअली जेतବେଳେ टुवर्ड्स कोस्ट आसे वेव रो हाइट टिके बढ़े एम्प्लीट्यूड बढ़े टिके काहे कि ना द वाटर बिकम्स शैलो डेप्थ शैलो हो गले कोन हो ना प्रेशर रो रिबाउंडिंग एक्शन ने बेसी पड़िबो प्रेशर बेसी हबो अगेंस्ट दिस लो and then the water rise will be relatively टिके अधिका हुए ओके आउ कोन क्वेश्चन अछि ओशन रो टेम्परेचर डिस्ट्रीब्यूशन रो peculiarity कोन what is the distribution of temperature and its variation over the earth surface ocean भितर कोन हुए normally temperature is relatively high in the equatorial area and equatorial area रे heating बेसी हुए by the insulation तापर gradually temperature कमी कमी जाए towards the pole in the inside the ocean on the surface the sea surface temperature ए भाबरे नॉर्मली थाए किंतु ई नॉर्मल सिचुएशन ता सब जगह रे हुए नाही काहे कि मन को को जगह रे वोल्केनिक इरप्शन से जगह हीट बेसी मिसी गला underneath the sea there are volcanic eruptions so there has been more heat generated and deposited and contribute to the heating process so there is a rise in heat and the heat distribution not necessarily because of insulation there are other factors which are also contribute towards simply current jemti warm current asile heat ro distribution बढ़िला गोटे जगह heat transfer ହେଲା तापर नेबरिंग एरिया रे कोन अछि दैट इज आल्सो अनदर इंपोर्टेंट फीचर से हॉट एरिया अछि कि डेजर्ट अछि कि फॉरेस्ट अछि कोन अछि ता ऊपर देयर इज ए सिग्निफिकेंट इंपैक्ट ऑफ दैट ऑन द ओशन then the temperature of the ocean also goes on varying across the globe and polar area रे तो polar ice caps अछि किंतु ता पर जो एरिया तो रहिला between the equator and the temperate zone आर्कटिक सर्कल और अंटार्कटिक सर्कल रो भीतर जो एरिया तक रहला ता भीतर टेंपरेचर वेरिएशन एमती हुए तापर जो पोलर एरिया पाखरे जो जगह आइसबर्ग जगह आसे the float icebergs they descend from the polar area ରୁ separate ହେଇକି ଯେତେବେଳେ सी ଭିତରକୁ ଆସିକି move କରି ଆସେ ତଳକୁ then they also bring a lot of cold effect to the ocean water ସେ ବି ଗୋଟେ ପାଣିକୁ ଥଣ୍ଡା କରି ଗରମ ପାଣି ଜାଗାରେ ଥଣ୍ଡା ପାଣି ପୁଣି ହେଇଯାଏ then there are several factors which are affecting to the distribution of temperature over the ocean ଆଉ temperature ବଢିଲେ କଣ ହୁଏ the ocean surface water will expand ଯେମିତି ପାଣିକୁ ତମେ ଗରମ କଲେ ପାଣିର ଯେତିକି ଅଛି ପଟ ଭିତରେ ହାଇଟ୍ ତାଠୁ ଅଧିକା ହେଇଯାଏ ନା ନାଇଁ ଗରମ କଲା ପରେ ସେମିତି ଓସେନ ଭିତରେ ବି ocean water also when they becomes warm they becomes uh, higher in altitude ତେଣୁ ଇଏ ଗୋଟେ ଫେନୋମେନା କ୍ରିଏଟ କରେ सी हायर होला पर कोन हुए ना गोटे स्लोप क्रिएट हो जाए स्लोप क्रिएट होले पानी रो मूवमेंट से डायरेक्शन को चले जो डायरेक्शन में स्लोप हुए तो दैट लीड्स टू द फॉर्मेशन ऑफ करंट तेणु सी करंट को लीड करे मन को गोटे जगह रे डेंसिटी बढ़ी गला ताहले कोन हमर सी अगेन लो डेंसिटी को पुश करिवो so there are various factors which are contributing to this phenomena in a differential form and understanding this for different type of understanding of the ocean behavior is important for any of the conclusions that you derive from these observations. ତେଣୁ ଆମକୁ ଜାଣିବାକୁ ପଡିବ ଯେ କୋଉଠି କୋଉ ଜିନିଷ କମ୍ବିନେସନ ରହିବା ଯୋଗୁଁ କଣ ହବାକୁ ଯାଉଛି ବା ହଉଛି anything that is happening. ତିନିଟା ocean ଭିତରେ ଆମର average temperature of the Atlantic Ocean is more. କାହିଁକି because Atlantic Ocean ର exposure to the cold area is relatively less than the exposure to the cold area of the Pacific and the Indian Ocean. पैसिफिक रे बहुत एरिया नॉर्थ साउथ पोल रे नॉर्थ पोल रे कोल्ड वाटर मिसुची आसिकी पैसिफिक रे लार्ज एरियाज आर देयर पर अटलांटिक रे कोन दी साइड टा लैंड लॉक्ड आ बेसी कोल्ड वाटर मिसुनी दूध पे कि हमरो टेंपरेचर इज रिलेटिवली हायर इन अटलांटिक ओशन देन अदर ओशन ओके ठीक अछि काली को टिके आउटे देखि के आसो देखि के आसी कि टिके पचरिया चेष्टा करो डिस्कशन करबा पे ओके टिके रखिबा जी
ଆଜ୍ଞା sir।
ନା ଆଉ କଣ ପଚାରିବ ପଚାର ନହେଲେ ଆଜି ଟିକେ ରଖିବା କାଲିକି ଟିକେ ଦେଖା ଦେଖିରେ ଆସିଥିବ ତମ ବ୍ଲକ ଜାଗା ତମକୁ କୋଉଟା ଇମ୍ପୋର୍ଟାଣ୍ଟ ଲାଗୁଛି ଯଦି ବୁଝିବା ଦରକାର ଟିକେ କ୍ଲାରିଫାଇ ହେବା ଦରକାର ଆଉ ସ୍ପେସିଫିକାଲି କୋଉ ଟପିକ ଯାକ ତମ ପାଇଁ ଇମ୍ପୋର୍ଟାଣ୍ଟ ସେଇଟା ଟିକେ କହିଲେ ହୁଏତ ଆମେ ଡିସ୍କସ୍ ଲିଟିଲ ମୋର ଇନ୍ ଡିଟେଲ୍ସ ଓକେ ତାହେଲେ ରଖୁଛି ଆଜି କ୍ଲୋଜ କରିବା
ଆଜ୍ଞା sir।
ଓକେ